now let's come to the interesting part, because what happened was we built a backtest, right? And the backtest that we run is actually fairly slow. And let's just check out how long it actually runs. Because when we, let's just pick one of those. And so, in Python, you have various profilers and so on. But what I do is I just use a simple time function. And we can actually measure the performance of this. So we go from time, import time. So this is just time. And what we can do is, and this is not perfect profiling, but it's actually quite handy. So we can go start equals time. So that basically gives us the time at the beginning of the run. And we go print time minus start. So that gives us effectively the time, the runtime of this backtest. And you can see it's 2.2 seconds, right? So, well, it's okay, 2 seconds. And we use, a reasonable amount of data looking back from 2009. But I have a feeling we can do a lot better than this, okay? And the question is, how can we do that? Now, if you were to use C++, that would be very different. But in interpreted languages such as Python, there's this idea of vectorized programming. And so what you do is, instead of running everything in a loop, you basically create a vector and you do all the operations that you want all at the same time inside that vector, rather than running a loop. Yeah. Makes somewhat sense. Okay, so the question is, how can we do that? And this is where this pandas package comes in handy, because what we've done is, we use in our backtesting code here, we have the SPY, and then we say, well, we take the close price, and then we calculate the average at every step of a look back window. So one thing we could do is we could do this all in one go. We could just calculate an average, and then we say, well, is the average above the price or is it below the price? And based on that, we can then create effectively an unrealized P&L. So let's have a look at that. This might seem a little bit abstract, but it will make a lot of sense very soon. So what we want to do is we say our moving average is equal to the SPY. And I said we only use close prices. Okay. So, and then what we also need to do is we need to go create a rolling window. So we go rolling. So this is a function in this package called pandas. Because SPY is already a pandas data frame, we can use it directly. We can go rolling, and then we need a lookback window. So let's just say we have a 200-day rolling lookback window. And then all we have to do is we have to specify what we want on this, what we want to act on this window. So we could, for example, have a rolling sum or a rolling whatever. In this case, we say we want a rolling average, a rolling mean, and so all we have to do is we go dot mean. Yeah. And that's what it is. And so what I want to do is I want to just quickly plot this for you. And I want to plot this with relation to the actual SPY. So let's do this. So here you can see we've got our moving average, which is the blue, and then we've got the orange. We've done this actually before, right? So we can basically plot the two together. Now here comes the interesting part. This wasn't really that fascinating, but what we can do now is we can do MA minus spider close dot plot. Okay. And now what we see is basically the difference between the price and the average. And so remember, if we're above the price, right, we go long. Or I'm not actually, I just need to check again what we did up here. So if our moving average is below our price, we go long. And if it's above our price, we go short. Okay. So what's probably better is if we go SPY minus MA, because long is, is basically positive and short is negative. So in order to get the signal, like a positive signal, we just go SPY or close minus MA. So when this is positive, we're basically long, we get a positive +1 signal. And when we're negative, we go short. And so if we do this, you can see there is a, okay. We still have the plot statement here, so that's not what we want. Okay, so you can see this here now. So it fluctuates between 0 or between positive and negative numbers. Okay, so you can see here when it's negative, we're probably in a downtrend here as well. And when it's above, we're in an uptrend. Now, that isn't really a good signal yet because we don't want like the real numbers. What we want is a +1 and a -1. So do you have any idea how we can get from this to a plus and -1?
Oh. Not really, I think.
Yeah, it's actually quite simple. We need to apply the sine function. So because these numbers are already positive or negative, yeah, we can apply a mathematical function called the sine, and in NumPy it's literally just mp.sine. Yeah. So we apply the sine, and now you see it fluctuates between +1 and -1. So in whenever it's at 1, we go long, and whenever it's at -1, we go short. Cool, isn't it? So these are our trading signals. This is effectively what we've already done, where we wrote all these lines of code in the backtest. We go long, we go short. Now we've already reduced that to this really simple function. Yeah. So there's actually a different way that I prefer to apply the sine function, and that's a bit more along the lines of pandas. And instead of doing NP, I go this structure here, dot apply, and then I go np.sine. So we've got the same sort of syntax, which is this dot operator syntax, and we just chain dotted commands to each other, right? And so if we run this again, we see the signals. Does that make sense to you? Any questions?
So if I understood it right, it means that we saw before that it was like over 0 and under 0, so like positive or negative. Yes. And what we're doing now is just like kind of like dividing it into like 1 and -1, like in a way, instead of like all the nuances, so to say, right?
Before we had like these little fluctuations, but actually when we trade, right, we're either long or short. When we basically say, well, if our price is above the moving average, we are long, and if it's below the moving average, we are short. That's all that we really want, right? And so all we really ask for is effectively that. And so what we do is we apply the sine function, which is basically just saying, well, if the sign of this specific value is positive, we do +1, and if the sign is negative, we just get a -1. And so we're either long or short in our trade. Does that make sense?
Yeah.
Yeah.
And so it's like right now at the graph that we see right now, it's like where we're like kind of on one, for example, we're like in a long position, and then when we go like down, we're kind of like in a short position until we go up again, and so on. Okay.
Exactly. So it
Yeah.
fluctuates between long and short. Okay.
Makes sense.
So that's the first part of what we're doing. We're creating the signals.